So let's get started with the introduction to AWS services as part of the Muscat Web Technology meetup. So in this session, I'm going to cover the following. The first one would be a quick overview of cloud computing. Then I'm going to cover a bit of overview of AWS, and then we'll understand some popular AWS services, and then we'll have question and answers. So as I mentioned, in this meetup, I'm going to cover the following. First would be a quick overview of cloud computing. Then I will also cover a bit of overview of AWS. Then we'll see some popular services of AWS, and later on we can have question and answers. So first and foremost, let's start with the definition of cloud computing. So cloud computing is, I think it's very prevalent in these days, and it has helped in some good quick innovation because of the reduced time to market. But if we talk about the definition of cloud computing is a model which enables convenient on-demand network access of shared pool of resources. Now, the key part is this shared pool of computing resources. So when you talk about computing resources, it can be anything, like it can be servers, storage, application, or services, right? So cloud computing is further divided into three models, that is three service models, four deployment models, and it has five essential characteristics. So if we talk about it, the five essential characteristics are basically on-demand self-service. So the first concept is to provision the resources, you don't need to go to anyone. You can directly on your own provision the resources. So this is on-demand whenever you require, and you can shut them off as well. Then it has a broad network access. Specifically for private or public clouds, you can just access it anywhere on the network. Resource pooling means you pool the resources into a central, you can say central pool, and you can, allocate those resources on demand basis. And then it has rapid elasticity. With elasticity, it means if the demand increases, you are able to scale up. And in case the demand is low, you are able to scale down. So elasticity is basically when there is a huge demand on a shorter period of time, you are able to expand your capabilities. It is a major services, just like you have electricity at your home. You pay for what you use. Similarly, for cloud as well, you pay for what you use. So that's why it's kind of a utility. So now in deployment models, you have public cloud, private cloud, community cloud, and hybrid cloud. So AWS is kind of a public cloud. You'll have private cloud, for example, OpenStack and VMware. Then you have community cloud. Community cloud is created by a close group of community. For example, if a government of any country creates a cloud and gives it to their own departments to use, that would be termed as a community cloud. And any other combination of the previous three deployment models, it would be hybrid cloud. For example, it can be public and private, it can be private and community, whatever. Sorry, so that is the hybrid cloud. And there are three service models, which is basically infrastructure as a service, platform as a service, and software as a service. So we are going to talk about this in this slide. So suppose you are a user. So we will term you as a cloud consumer. You consume cloud services from a cloud service provider. Let us assume this cloud service provider is AWS. And you use the services provided by the CSP, and there is a formal agreement between you, basically what type of services you are using, how much you have to pay. This is a kind of formal agreement. Just like when you take a mobile subscription from a provider, you enter into a formal agreement. Hey, Mohammed, welcome to this uh, meetup. I'm recording this session. I'm talking about the cloud provider model. As of now, this is part of a bit of introduction to cloud computing. So, yeah, you can ask questions in case you have any. So, I was talking about the cloud provider model. Basically, there is a cloud service provider, just like Amazon. It is a service provider, just like, for example, you use services from Omantel, right? So Omantel is the service provider, and then you are the user. So there is a formal agreement in terms of what type of services Omantel would be providing. Similarly, there is a formal term of agreement which AWS would be providing, right? So we have the cloud consumer and there is a cloud service provider. Now, if we talk about service models, and if we think of whenever we're deploying our web technology on any infrastructure or anywhere, we would need servers, we would need database, and we would need some sort of we can say resources where we can put compute, networking, or uh, our storage, right? So this is the infrastructure. On top of infrastructure, we would have operating system. So for example, on servers, we put operating system, mostly Linux. And then you will have some sort of middleware system to manage, you can say, these operating system, as well as some sort of communication between the runtime libraries and operating system. You'll develop some application, or you will use those applications. You will have some data. So this is the stack. Now, in case the cloud service provider is managing only the infrastructure and you are managing the rest of the things, then this type of model is called infrastructure as a service. If the cloud service provider is managing till runtime libraries, it is only your responsibility to manage your data and application, then this is called platform as a service. And last, if everything is managed by cloud service provider till application, then this is called a software as a service. Example is if you're using your Google Sheets, right? Or yeah, Google Writer or anything on the web interface. So that is a software as a service where you just need to manage your data. Similarly, suppose you are using uh, any platform as a service capability. For example, you're deploying something on AWS Lambda, which is a platform as a service. You deploy the application as well, and you manage the data as well. So this is a example of platform as a service. AWS generally started with infrastructure as a service, with the EC2, S3, all these kind of services. But then later on, they quickly, provided a lot of platform as a service capabilities, and which they branded as serverless. And we are going to talk about it soon. So this is the service models. Now, I've just given a quick, you can say, differentiation. I will just share these slides as well in the group. So you can, go through it. What are the differentiation between SaaS, PaaS, and IaaS, or infrastructure as a service? So we are talking about AWS, and I'm an AWS community builder. Basically, I work with AWS in terms of you know their new solutions as well as technologies, as well as getting much more awareness. I run boot camps, etc. So AWS is the wide range, or you can say one of the biggest market player in cloud computing. Accurately, it has around 40% plus market share, and it is the biggest hyperscaler, and it provides around 2000 sorry, not 2000, 200 services, which include computing, storage, database, etc. And we are going to, take a look into these services. The best part is it is available on demand. It is built on per second basis with a pay as you go model, and you pay for what you use. And there are a lot of tools. Uh, we are going to take a look onto a smaller, you can say smaller group of tools, but which are very important and very popular. So first and foremost, AWS regions. So there are 33 launched regions. So regions are basically data centers, or you can say the group of data centers into a city. For example, if you see here, the closest one that I know is in UAE, and then it's in Saudi Arabia. So we have AWS has 105 availability zones, and then CloudFront point of presence. So basically, this is used. Suppose you are watching you can say video on your phone, you would be connected to a nearest CDN, that is CloudFront. CDN is a content delivery network, which would cache those video, and so that it's easily available to you on without any delay. So 33 regions, it is one thing to remember, 105 availability zones, and we are going to see what are the difference between them. So let's try to understand some of the services, and we'll see from there. If you have any question, just let me know and possibly I can take them up. Let me just open the pen here. All right. So let's start with the infrastructure as a service, and I will give you an example. Suppose there is a person who, we come from a web community, right? And everyone wants to build some projects. So suppose there is a person who wants to build a website for used cars, right? I just took this as an example, that's just to show. So initially, what the person can do, or what, if suppose I'm building this, what I can do is I can create a basic HTML website, right? I can create multiple pages, for example, car1.html, car2.html, depending upon uh, what are the used cars in the inventory. And I can, you know, put the images in those HTML files as well as some details about them. Now to run, or you can say to execute this HTML, I need some sort of servers, right? I can probably create those servers on my laptop or my PC. So these servers are basically which would be running your either Apache HTTP D server or Nginx. So if we have a server that would basically uh, can do the job, but mostly if you are running a bigger website, you would probably need more servers. So we would have a server rack which will have multiple servers, right? And these multiple servers can work in different ways. We can create a cluster out of them, or we can, just individually have different uh, type of applications running on these servers. So generally, this is the server rack that we have. Now, these server racks are connected with a top of rack switch, where we have the layer 2 networking. I mean, we connect LAN cables with this top of rack switch, and then we create some networks internally, which would be the part of the private subnet. So these private subnets are free to use. So we take anything, like for example, we can take 192.168.0.0.16 to create a network. Now, this is similar to what we do at our home in routers as well. We use 192.168, this sort of IP address, to connect our laptop or our mobile phone on the network, right? Now, to connect to external world, we need a router or the gateway, which would provide us the layer 3 networking. And this router will segregate our private network and a public network. So this private network basically will have all our communication inside the, you can say what we are hosting, and the public IP would be the external interface. And to do this mapping from public to private, we need some sort of technology that is provided by NAT, or the network address translation. So suppose we have an IP 5.1.1.1, and we have all these IP, for example, .1, .2 in the .3 in 192.168, blah, 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 .1, .2, .3. So this, which server it has to hit, it is managed by the NAT, network address translation. So this is how your communication works inside a network. Now this public IP is basically mapped to a domain name. For example, we bought a domain xyz.com. So what we will do, we have to store this entry somewhere. So we would need some sort of, you can say server, which is called a DNS. And what we also can do is we can create our internal uh, canonical names for our servers, server 1, server 2, server 3, dot internal dot xyz.com, etc. So that is stored into a DNS, and these are the A entries that we have inside our, you can say, DNS. Now, suppose I'm working remotely, right? I need to SSH into these servers, so I need some sort of way to just allow a specific IP to, log into that port, that is SSH port. So we can add some entries like allow 2020, that is the SSH port, TCP 2020, and deny rest of the ports. So this means I can remotely log in from anywhere. And this is called an network access control list. So this is how you manage your infrastructure, and you host it on a web hosting platform where basically once you have all this DNS configuration, your server configuration, and you host your website, you would be able to make your website live, all right? But the problem is scaling. An HTML-based website won't scale much. So what we need to add some dynamic programming languages, for example, JavaScript, PHP, or Python for our backend work. And we can use some routing principle that we have in web technologies where we can route our, you can say, uh, endpoints to display dynamic pages, right? And that's why we need some sort of database, SQL or NoSQL, and we can store some static media, etc., into a page. And this dynamic content is generated on demand, right? And when this on-demand content is generated, right, this media is loaded differently, and this text can be generated differently. And this processing is done by the server. Now, what it does is that it uh, separates our data and our compute. So once it separates our data and compute, we are able to scale better. So now we can increase the compute, right? So what we can do, we can suppose there is a lot of reads on the database, we can add a DB cache. So it will cache those reads, and then we are able to, retrieve better. And then we can scale our servers horizontally by adding a load balancer. So load balancer would see what is the state of these servers. If it is highly loaded, it can move the traffic to other servers depending upon whatever load balancer we have configured, right? So this is how we scale our websites better. Then what we need to do, we need to add a firewall, right, to protect our website from a DDoS or DOS attacks. And this would somewhat look like our final architecture, not pretty efficient, not still, you can say, up to date to the modern architecture, but this is a basic three-tier architecture that we talk about. And we talk about this three-tier architecture, this is something it, look like into a block diagram where you have your web, where you have firewall, load balancer, then you have your compute, then you have some sort of cache, and then you have your database, either SQL based or relational or NoSQL database. And if we lift and shift this directly to AWS, what would happen? All the all the services that I show you here is basically what we can, directly copy from this previous slide. So we'll have a load balancer in AWS. It is Elastic Load Balancer, ELB. Then you have EC2 instances, which are basically your compute. Then you have some sort of caching here. And then you have RDS, which is your relational database. And then you can use DynamoDB for NoSQL based database. So this is a lift and shift architecture. We can use web application firewall, which is basically your firewall which can protect from DDoS attack. But this is a very high level, you can say, view in terms of your architecture that we build on AWS. If we talk about how we deploy our EC2 instances, we can deploy our EC2 instances into multiple ways. The first and foremost way is basically we put all the EC2 instances into a single availability zone. So now if you talk about availability zone, is basically availability zone are, if we talk into, suppose this is a city, right? Let's take an example from Muscat, right? So in Muscat, suppose AWS want to build their data center, or you can say they want to build the region. So what they will do, they will take multiple regions. For example, they will build a data center in Bosher. They will build another data center far from the city into a different flood zone, and then another data center into a different flood zone. Basically, if there is a high chance of rain, uh, all these three should be into a different flood zones. So these are called AZs, AZ1, AZ2, and AZ3. So these are connected with high capacity fibers. So there is a very little latency. And what happens, we can deploy our compute into different AZ altogether. So what would happen? Suppose this AZ goes down for XYZ reasons, we are still served by these two AZs. So this provides a higher resiliency. So this is how you will try to, create uh, your architecture. If you want to have, so this is how you will try to create a high resilient architecture. What you will do, we will try to move our EC2 instances, right, into different availability zones. So this is EC2 and this is EBS. EBS is a elastic block store. So your EC2 instance is, think of it, it has compute, and with EBS you attach a bit of disk. So you can have 20 GB of disk here, and then you have EC2 which is providing your compute. It is basically a server running Linux or virtual machine. Now what we can do, we can use a concept called auto scaling group. What would happen with auto scaling group? We can say, okay, right now I need only 3 instances of EC2, but as soon as the load increases, I want to make 9. So auto scaling group, suppose the CPU uh, load moves to 60%, we can have a trigger. As soon as the CPU load goes to 60%, it will spin up another one. And as soon as both of them are more than 60%, it will spin up another one till it reaches a total count of 9. So this is an auto scaling group, which would probably, uh, scale up your services on demand. And that is what elasticity means. It will increase your resources based on demand. So here what I'm showing is the 3-tier architecture that we would map into a VPC. VPC is a virtual private cloud. And suppose we take a subnet for 10.0.0.0/16. What we can do, we can create 3 subnets. Suppose we can have 10.0.0.1, 1.0/24 for public. This means anything which needs to talk to the outside world, we can put into the public subnet. We can have another subnets, for example, 10.0.2, 0.3, and 0.4 for our private subnets, right? And in different AZ, we will have different subnets. Okay. And similarly, for our database, we can have different subnets. So what happens, suppose if we need to connect, we can only connect from outside world into the public subnet, right? So this provides a better resilience and better security in terms of your compute as well as your database. So your database cannot be accessed from outside the world. It can only be accessed from this private subnet. So this is how a 3-tier architecture is deployed. So I've just given a brief overview of a few infrastructure as a services. Now, if we talk about platform as a service, it is branded as serverless in AWS, but it technically it would still require some servers to run. So serverless means you don't need about managing servers. You don't worry about them. You just write your code and you have your data, and then you use some platform as a service to run it for you. For example, you will have AWS Lambda, which is very famous. It provides you the compute. You have API gateway, which helps in you can say creating APIs, and you can have internal as well as external APIs. Then you have DynamoDB, which is NoSQL database. You have S3, which is object storage. And then you have SNS for notification. You can use it to send SMS. You can use it to send email notifications as well. And then SQS, so queuing service. So you can have queues where you can send messages. And this is very important in serverless architecture. So suppose if you want to add an S3 bucket, what we can do, we can add an S3 bucket. Suppose this S3 bucket will store all the images, and we can use a CDN or the content distribution network called CloudFront to serve those images, right? We can also use Lambda, for example, if you want to run some ad hoc jobs, some cron jobs, or maybe you want to do some compute on, or you can say task on some images on S3 buckets, you can use Lambda. And as you can see, I've put this Lambda into a private subnet. So we'll stick to the same definition. We'll put all the compute into a private subnet. Next is your APIs. You can use API gateways, and you can expose the API gateways by putting it, for example, I have put an API.xyz here and an internal API here. So you can use API gateway to expose your APIs as well. And because this is an API, we are going to put it behind a WAF. We can also use SNS to send some notification, SMS or email notifications. Next thing is we can use monitoring and management, which is very important. Like for example, VPC flow logs, which is something related, something similar to T-Shark or Wireshark, which can help you collect some traffic logs. Then you can use CloudTrail, which is who has accessed what, CloudWatch, which will give you some metrics. And IAM is uh, the identity and access management. It helps us create user policies, roles, etc. Basically to restrict and allow uh, you know entities or users or connectivity between various services. So this was a brief overview of AWS services, very high level, and something related to web. There are multiple other, you can say services. For example, in compute, there is a complete list of services here. On containers, we have ECS, ACR, EKS, that is Kubernetes. So if we have another session, I can, also talk about containers. We'll have database services. As I mentioned, there are more than 200 plus services. So this is a kind of a simple list of services that we have on AWS. So that's it from my side. In case you have any questions, just let me know. And we'll probably, give a brief introduction about myself as well before I jump out. So I'll share the slides in the group. So as I mentioned, I've created this group a few years back. It was dormant, but I'm trying to revive it. So in case you want to present, just reach out to me. And in case you want to also host, uh, you can reach out to me as well. So I'm basically an online trainer. Have trained a lot past few years. So you can reach out to me on YouTube or you can reach out to the website. Uh, this course is going to start uh, from next week, AWS Bootcamp. However, I also have free courses on my website, learn.mohitkiar.com. And this is my Udemy snapshot. So in case you want to host, just reach out to me if you want to present a topic, or if you want to physically host a meetup, or if you need some support in terms of mentorship, etc. Yeah, that's it. Any questions? So for data analysis, as I mentioned, in the end, there are some services. I'll share this slide deck with you on the group, as well as you can just download it from there. But yeah, so data analytics would be part of some of the services from machine learning you can use, as well as there is the one of the famous one is Amazon QuickSight, and the other is Amazon Q, which is implementation of machine learning on top of QuickSight. So these two are some of the services which are something similar to Tableau and Power BI. So that's it from my side. Any questions or anything? I would also, love to hear from you what you guys do, what you work with. I will try to, have multiple session in a month. So reach out in case you want to present something. It is good for presentation skills. It is good for connecting. It is good for promoting your work as well. Thanks for joining this session. I will probably host this recorded link and then share it with you guys. Any questions? All right. I will close the session. Thanks, everyone. Have a good night.